This is the Unit 2 review for Algebra 2 Honors, and we're going to do 1, solve each equation and check for extraneous solutions. So on part A, we have a quadratic equation. We're going to set it equal to 0 so we can solve for x. This is not factorable, so I'm going to use quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c over 2a. So negative b plus or minus the square root of 100 minus 12 is 88, and then divided by 2. We can simplify the square root of 88. Square root of 88, if we split that into a perfect square and another number, we know 4 goes into 88 and then times 22. I know square root of 4 is equal to 2, so that's going to come out of the radical. Square root of 22 stays, and then divided by 2. And then all of these need to be, both of these need to be divided by 2, so our final answer will be negative 5 plus or minus 1 square root of 22. On part B, we have a square root on this side. To get rid of the square root, since it's already by itself, we can square both sides, because the squaring is the inverse of square root. So this squared undoes the square root, so that becomes x plus 2, and over here we just have x squared. Now we have a quadratic. If we set it equal to 0, we can solve. Check if it's factorable. We can do negative 2 times 1. And because a equals 1, I'm going to go ahead and write my factors as x minus 2 times x plus 1. And then the zero product property gives me x equals positive 2 or negative 1. We need to check for extraneous solutions, especially when there's a square root. Oftentimes you'll see an extraneous solution. So plugging 2 in, square root of 4 equals 2. That one's okay. If I plug in a negative 1, that becomes square root of 1 equals negative 1, which is not true. So this is extraneous, and our only solution is 2. On part C, we have a square root. However, the square root is not isolated, so I'm going to isolate it by adding 3 to both sides first, and then dividing by 2, or dividing by negative 2 on both sides. Now that the square root is isolated, we can square both sides to get rid of the square root. And then we just have a linear equation, so 2x equals 48, x equals 12. And again, I'm going to check for extraneous solutions, so if this is a 12, that's square root of 25 is 5 times negative 2 is negative 10 minus 3 equals negative 17. Oops, I plugged in the wrong number. So this is 12 times 2. It's not 12, it is 24. That's why it didn't work. So 24 times 2.
Justin Revega, please report to the attendance window. Justin Revega, please report to the attendance window.
Alright, so plugging 24 in is, so square root of 49 is 7. 7 times negative 2 is negative 14. Negative 14 minus 3 is negative 17. So this is a solution, it's not extraneous. On part D, we have a trinomial. I'm going to check if it's factorable first, and it is. But be careful not to go straight to your factors like we did here, because a is not equal to 1. So I cannot just say x plus 6x minus 1, or 3x plus 6, x plus 1. I'm going to factor by grouping, so that's going to be 3x squared. This gives you the terms that replace the middle term, so plus 6x and plus 1x, and then the plus 2 stays. And then I'm going to factor by grouping. So in this group, the common factor is 3x, and in this group, the common factor is just 1. And then my final factorization the common factor is x plus 2, and then the other factor is whatever's left, the 3x and the 1. So zero product property would give me x equals 2 and x equals negative 1/3. X equals negative 2. All right, number 1e. I'm going to go ahead and get rid of that 1/4 by multiplying both sides by 4. And then I want to isolate x. So to get rid of the squared, I'm going to do the inverse, which is square root both sides. X minus 1 equals. And since this is squared and I'm getting an answer of 36, this could actually be plus or minus 6. So x equals 1 plus or minus 6. That would be x equals 7 or negative 5. On this one, we have a square root again. I'm going to square both sides. Over here, this is x minus 5 times x minus 5, which is x squared minus 10x plus 25. If you FOIL, that is what you would get. And then I'm going to set that equal to 0. So x squared minus 11x plus 28 equals 0. This is factorable, x minus 7 times x minus 4. So x equals 7 or 4. Let's check for extraneous solutions. If we plug 7 in, that's square root of 4, which is 2. 7 minus 5 is also 2, so this one checks. If you plug 4 in, square root of 1 is 1, but 4 minus 5 is negative 1, so that doesn't check. So this would just be x equals 7.